Our goal for today is to be able to solve radical equations. So they're equations that have radicals in them. But before we do that, I just want to quickly do a little reminder of how to solve equations. Now remember, your goal to solve an equation is to get this x by itself. So to do that, my first step here would be to add 7. So I get 3x equals 12. And then I have to divide by 3, which 12 divided by 3 is 4. Now, most times we would just stop there and move on. I want you to keep in mind when we're dealing with radicals, it's very important that you check your answers. So I just want to show you an example of how we would check our solution. So we have 3x, but instead of x, we're going to put a 4, plus 5 equals 7. 3 times 4 is 12. Okay, and what's 12 minus 5? Oh, cool. So 7 does equal 7. So this is a correct answer. And that's why x plus 4 works. I'm sorry, x equals 4 is an answer. It's a solution. So I also want to remind you of another example. So here, I could subtract 4. I get 2x squared equals 18. And then I want to divide by 2. I get x squared equals 9. Now, if you remember, when I square root to get rid of a squared, I have to put a positive or a negative when it's a square root. And the square root of 9 is 3. Now, this is how we're going to check. If I have two answers, I have to check both the positive and the negative. So 2 times positive 3 squared plus 4. So positive 3 squared is 9. 2 times 9 is 18. So that works. So the positive 3 is good. And then I also have to check it with the negative 3. Now be careful, make sure it's in parentheses because a negative 3 squared is 9. And then from here, we already did the rest of the work. We know this is 22. So actually, both values work. I have both a positive 3 and a negative 3 as my answer. And in this last example, I can't easily do what I just did in example number 2 because I have x squared, x, and a number. In example number 2, I only had the x squared. I had no other variables. So that's why I was able to do that. So here, my first step is to get this equal to 0. So I just moved over my negative x and positive 6. And then from here I have to factor. This is an add multiply rule. So if I want to multiply to a negative 6 and add to a positive 1, positive 3 times negative 2 is negative 6. And then positive 3 plus negative 2 equals positive 1. So if x plus 3 equals 0, x equals negative 3. So you really have to bring everything that we've learned so far into this. Very important that you know how to factor by now. So let's check. Negative 3 squared equals negative 3 plus 6. So this is 9. And then a negative 3 is a positive 3. So 9 equals 9. So actually, before I even box these off, I just want to check that it works. So negative 3 worked. We're good. And then I'm also going to check a positive 2. 2 squared equals negative 2 plus 6. So this is 4 equals negative 2 plus 6. So 4 equals 4. So this works as well. So here is our final answer there. So that's why we didn't check as often when we were just dealing with equations like that because it kind of just works out every time. But when we're dealing with radicals, it is very important for us to check because with the radical, with the square root, remember, positives and negatives, sometimes things happen where it does not work out correctly when we're solving because we have to square. So in this first example, I want you to recognize your goal is to make sure your square root is by itself. So notice on this side of the equation, the square root is by itself. There's nothing outside of it, okay? So once it's by itself, the opposite of a square root is to square it. So I could actually square both sides, and it'll get rid of this square root. So I'll be left with a 3x minus 2 equals 4 squared is 16. Then if I add 2, I should get 3x equals 18. And then if I divide by 3, I get x equals 6. Now again, it's important for you to check your work. So I'm going to check here. So always plug it back into the original. So I'm writing check. That looked like I wrote something else. So here's my check. So I have the square root of 3 times 6 minus 2 equals 4. That's what we're trying to check. So it's the square root of 3 times 6 is 18 minus 2. And this 18 minus 2 is 16. And the square root of 16 is 4. So yes, it worked. Therefore, x equals 6 is a correct solution to this equation. So that's one type of problem. Look at number 2. Is the square root, when I look at this, is the square root by itself? No, I have this plus 5 on the outside. So I actually have to move that over first by subtracting it. I get the square root, the square root of x minus 3 equals x minus 5. Now that the square root is by itself, I can square both sides because the square will get rid of the square root. And I'm just left with x minus 3 equals. Now, x minus 5 squared means x minus 5 times x minus 5. So you have to distribute and then combine like terms. Now I'm very quick at doing this already. I already know my answer is going to be x squared minus 10x plus 25. Now you could do the work here on the side and figure it out, or maybe you want to take out a piece of loose leaf paper, but I already know how to do that math separately. Now because this is a quadratic, I want to get it equal to 0. So I have to subtract over the x and add the 3. And then now I have to factor. So I have to think of two numbers that are going to add to a negative 11, but multiply to a positive 28. So I believe if I, do the math on the side if I need to, I get negative 7 and negative 4. So with x minus 7 equal to 0 and x minus 4 equal to 0, I get x equals 7 and x equals 4, but I'm not done. I have to check my work. So I'm going to do a little check here. I have to check each one. So the square root of 7 minus 3 plus 5 equals 7. 7 minus 3 is 4. The square root of 4 is 2. And 7 equals 7. So 7 works. And then I have to do another check for the 4. But let me just make this a little smaller. So now I'm going to do the square root of 4 minus 3 plus 5 equals 4. Square root of 4 minus 3 is 1. Square root of 1 is 1. 1 plus 5 is 6. I think I did something wrong, but no, actually I didn't. Looking at my work here, that just means, since this did not work here, that means this is not an answer. This ends up getting rejected. It's called an extraneous root. Does not work. Pause the video whenever you need to. I'm just going to continue working here. I want to get the square root by itself, so I'm going to add x So square root of x squared minus 9 equals, I like to write this as a positive x minus 3. It's up to you. If you write it the other way, it's not wrong. It's just easier this way for me. So now I'm left with x squared minus 9 equals, this is x minus 3 times x minus 3. So I get x squared minus 6x plus 9. Now when I subtract x squared from both sides, look what happens. I'm left with a negative 9 equals negative 6x plus 9. So when I subtract 9, I get negative 18 equals negative 6x. And then I get that x equals 3. So if I'm going to check my work, let's see if this works. 3 squared minus 9 minus 3 needs to equal negative 3. So let's see if I did this correctly. So 9 minus 9. And I get 9 minus 9 is 0 minus 3. So negative 3 equals negative 3. Hey, that works. So this is a correct answer. Always important to check. Look what happened in number 2. If you didn't check your work, you would have gotten 2 answers. But really, there's only one correct answer there. Okay, look at number 4. It's a little different. Now I have 2 radicals, one here and one here. So I can't just square this whole side. So the trick is to put one radical on one side and to move this radical to the other side so that when I square both sides, the radicals go away. So watch this. If I add the square root of 2x plus 7, I end up getting that the square root, I'm trying not to take up too much room, of 3x plus 2 is equal to the square root of 2x plus 7. Now that I have the radical on both sides, I can just square both sides. So here it gets rid of it, and here it eliminates it. So I'm just left with 3x plus 2 equal to 2x plus 7. Which is, very easy to solve now. If I subtract over the 2x, I get x, plus 2 equals 7. If I subtract over the 2, I get x equals 5. Before I box that off as one of my answers, I have to check. Is that a correct answer? 3 times 5 plus 2 minus 2 times 5 plus 7 equals 0. So I get the square root of 15 plus 2 minus the square root of 10 plus 7. So 15 plus 2 is the square root of 17 minus the square root of 17. Oh, it looks like it does give us 0. So since this works out, x equals 5 is an answer. Ooh, look at number 5. Again, I have 2 radicals, so I want to make sure one of them gets moved to the other side. This might end up looking a little bit different, so it's going to be a little challenging. But I think you can handle it. So here I get the square root of x minus 5 equals 2 plus the square root of x. Now, I cannot add those two. Now, when I square both sides, look what happens. So here they just cancel out on the left side. So I just get x minus 5. But on the right-hand side, I can't just cancel that out because the whole thing is not a square root. So I actually have to do some math on the side. I have to do 2 plus the square root of x times 2 plus the square root of x. Now I suggest you get a piece of paper to try that out. I want to see if you could do it correctly. We've practiced this earlier in the week. If you do it correctly, you should get 4 plus 2 times the square root of x plus x. Okay, so if you do that correctly, that's what you should get. Now, if there's any like terms to combine on this side of the equation, you combine them. But since there's not, I'm actually going to subtract the x and subtract the 4. So that I'm only left with a 2 radical x here. Really important to get the radical by itself. So the x minus the x cancel out, And then a negative 5 minus 4 is negative 9. All right, we're almost done here. Now I want to divide by 2. So if I divide by 2, I get the square root of x equals, well, negative 9 divided by 2 is a negative 4.5. And then, to get rid of this radical one last time, I have to square both sides so that it gets rid of it here. So once you square this, you get that x equals 20.25. Now, we did all that work, but we still have to check it. So now I'm going to check it here. So we have the square root of 20.25 minus 5 minus the square root of 20.25 has to equal 2. So let's try this out. 20.25 minus 5 is 15.25. And is there a square root of 20.25? Yes, I did it in the calculator and I got 4.5. What's the square root of 15.25? Ooh, I got a weird decimal. I get 3.90512 ... It's an irrational number. If I try subtracting 4.5 from that, will I get 2? So when I subtract 4.5 from that, I get a negative 0.59487. An irrational number, which I should. And is that equal to 2? No. So it does not work here. So the check does not work. So this is not an answer. So there actually, if you take a look here, there's no other answer to check. So really, this has no solution because nothing worked here. The answer we got didn't work, and there's nothing else to check. And here's the last example I want you to see. I want you to take a look. What happens when it's a cubed root? So instead of squaring it, we're going to have to cube it. So first thing, I need to get the radical by itself. So now I have the cubed root of 5y plus 2 equals 3. And then to get rid of a cube root, I have to cube it. So I get 5y plus 2 equals 3 to the third power is 27. Then I subtract 2, I get 5y equals 25. And then I divide by 5, I get y equals 5. I still have to check my work. This is the last thing I have to do to make sure I'm doing this correctly. The cube root of 5 times 5 plus 2 minus 3 equals 0. The cube root of 25 plus 2. See how I'm doing every single step. So here I get 27. Now I'm going to check in my calculator what the cubed root of 27 is, which is 3. Is 3 minus 3 0? Yes, it is. So y equals 5 is a correct answer. So here I've done 6 examples with you. I know I moved pretty quickly. If you need to pause, you can do so wherever you need to. Here are 6 examples that look just like it. So here I zoomed a little bit in so you could see them. So here are 6 examples I want you to try. And then I want you to come back whenever you're done. So pause the video now and come back and I'll have all the answers with all the work there for you. Okay, so hopefully you finished these 6 questions. I actually had all the answers here that I wanted to copy up for you. I had it prepared for before. So there we go. So I'm going to zoom into each one. Pause when you need to. Check your work. So first answer, x equals 4. For the second answer, x equals 23. For the third answer, x equals 2. For the fourth answer, x equals 2. For the fifth answer, I have to zoom out a little bit so you could see all the work. I got 2 answers and they both worked when I checked them. I got x equals 3 and I got x equals 11. And for the last one, I got x equals 1. So in all 6 of these problems, you should have gotten an answer. They should have all worked out, even if you checked your work. So if you have any questions, feel free to ask, and I will see you guys next time. Have a great day. Bye.